Hi guys and girls, a video here on lowest common multiple, which just means like the smallest number that is in both of the times tables, which will be more clear when I start doing some. Okay, so there's two ways you can do it. There's the list way, which really relies on you knowing your times tables, or at least being able to work them out with no mistakes, because if you make a mistake, it just won't work. The other one is the factor tree method, which, yeah, you still need to know your times tables, but they don't generally have to be high times tables. Right, I'm going to show you, so let's get my pen to work, find the lowest common multiple of 12 and 16. So if you're doing the list method, you would just write out the times table. So write out the 12 times table. So 12, 24, 36, 48, 60, 72. Things you don't really know when to stop. You've got to do it with the other one as well. So we've got to do 16, 32, 48. So I've got a 48 there and a 48 there. So my lowest common multiple is 48. It's not too bad, that one, because we didn't have to go that high. I'm going to show you the other method, and then I'm going to show it with some higher numbers. So the tree method, we start with 12 up, and then we want, first of all, we need to know our prime numbers, don't we? Now, if you need to go back and recap prime numbers, do so. If you need to go back and look at my video on how to do trees, factor trees that is, do that. Yeah, I mean, I'll explain it as I go, of course, but it's going to be easier if you can follow what I'm doing rather than trying to learn two things at once. So, something that multiplies together to make 12. Let's do 3 and 4. Doesn't matter what it is as long as it times together to make 12. Actually, I would say avoid 1. 1 will not help you, just like dividing. 1 won't help you. In this sense, it won't help you either. So 3 and 4. Are 3 and 4 prime numbers? Well, 3 is. So 3 goes in an apple. And once you've got an apple on the end of your branch, it can't go any further. 4 is not a prime number, so we need to split 4. So a timesing sum that makes 4. 2 times 2. 2 is a prime number, so it is an apple. And we can't go any further because we've got apples on everything. We do the same with 16. 4 times 4. We do 2 times 8. And it doesn't actually matter how you split them up, because they will always split the same way in the end. You just have slightly different shaped branches. No trees are going to be exactly the same if they split differently, if that makes sense. Anyway, so what do we do with this? Well, for 12, I've got 2 times 2 times 3. Start with the lowest numbers and go up to the highest numbers. For 16, I've got 2 times 2 times 2 times 2. Okay, then we look at pairs. So those two 2's make a pair, they match. And those two can make a pair, they match. I can't make any more pairs because although I have a 3 in the top row, I don't have a 3 in the bottom row. Or similarly, because if I've got 2's in the bottom row, I don't have any more 2's in the top row. Now, from here, what you do is you go, right, well, they're doubled up. I don't want them to be doubled up, so I'm going to cross some out. And it doesn't matter where you cross them out, top row or bottom row. I would advise, if you're going to do top row, do them both from the top row. If you're going to do the bottom row, do them both from the bottom row. It doesn't actually matter, but it's easier. So I'm going to scrub out the bottom row for this one. You can get rid of the boxes if you like. So the top row, we know all of this makes 12. And what we've got left here is 4. So what is 12 times 4? So our lowest common multiple, 12 times 4 is 48, which is exactly what we got up there. Now I imagine a lot of you are sitting there thinking, well, that was so much quicker and so much easier. Don't forget, I've started with easier numbers because I can show you the method. If I now show you some harder numbers, hopefully you might see that the tree's slightly more reliable. Okie dokie, let's go with a harder number one. So let's do the lowest common multiple of, let's go with a 26. Actually, that's not a good number. Let's go 28. 28 and 32. Okay, so lists. 28 times table. Well, do you know your 28 times table? It's not easy. 56. The next one will be adding those two together, which is 84. And then 112. And then, sorry, I said an itch. What was I doing? Oh, so the next one will be adding on another 28 to that, which would be 140. And then adding on another 28 would be 168. And I don't know whether I need to stop or not. I need to do my 32 times table, so I've got 32. 32 and 32 make 64. And another 32 would make 96. It's not looking great. Then 128. Then another 32 on top of that is going to be 150. No, 160, sorry. That's it. It's really easy to make mistakes as well. And then 192. Oh, and yeah, I could keep going for ages. So let's try the trees. So 28. Give me a timesing sum that makes 28. What about 2 times 14? Could do 4 times 7. 2's prime, so it goes in an apple. 14's not. Give me a timesing sum that makes 14. 2 times 7. And that was in the prime number list as well. Where is it? There it is. 7. So 7 goes in an apple. 28 is done. And 32. Give me a timesing sum that makes 32. 2 times 16. Could have done 4 times 8. 2 belongs in an apple. 60. So we could do 2 times 8, or we could do 4 times 4. Doesn't matter. I'm going to go with 2 times 8. 2 belongs in an apple. 8 needs to split. 8, I could do 2 times 4. 2 belongs in an apple. And 4, I can do 2 times 2. And so it's a longer branch, but really you're only halving things. So, if we write out 28, we've got 2 times 2 times 7. And for 32, we've got 2 times 2 times 2 times 2 times 2. There's 5 2's there. 2 times 2 times 2 times 2 times 2. So pair up. So they match and they match. There's no more 2's on the top, so I can't match any of those, and there's not a 7 on the bottom either. So we don't want to have double ups, so we're going to cross out. I'm going to cross out at the bottom row again. Personally, I always cross out from the higher number, but like I say, it doesn't matter. Okay, so we know that this lot here makes 28. And what we've got left here is 2 times 2 times 2 is 8. So we need to work out 28 times 8. You can use whatever method you want to work that out. You can chunk it, you can do Napier's bones, you can do columns, you can do what you want. Alright. You could get these in non-calculator papers, so I wouldn't head straight for your calculator. I quite like Napier's bones. It's so simple. So 28 times 8. So the tens go in the top of the box and the units go on the bottom, or the ones, so tens and ones. So times them together, 8 times 8 is 64, so 6 tens and 4 ones. And then 2 times 8 is 16, so it's 1 10 and 6 ones. And then you add up the diagonals. So if you start here, that diagonal there makes 4. This diagonal is 6 and 6, that's 12. So you put 2, carry the 1 up. And then that diagonal is 2, so the answer is 2, 2, 4. Alright. I know a lot of you will prefer columns. So 28 times 8, 8 times 8 is 60. 64, 8 times 2, but that's actually a 20. 8 times 20 is 160. Add them together, it's 224. But it doesn't matter how you get there, as long as you get there. Alright, so you can see, I would have to keep going up these until I get to 224. Whereas for this, really the only difficult sum I've had to do is that one, rather than constantly adding on some really awkward numbers. One more, just to make sure we've got it. Let's do the LCM of 45 and let's do 100. No, let's not go in the hundreds. That's mean of me. Let's do 27. Hokey cokey. So I'm just going to go with the trees. If you haven't guessed by now, the trees are so much better, which is why I'm trying to kind of push you in that direction. So 27. Give me a timesing sum that makes 27. 3 times 9. 3 is a prime number. 9 is not. 9 needs to split. That is 3 times 3. 3 is a prime number. There you go, 27 done. How quick was that? 45. Well, it ends in a 5, so I can do 5 times something. So that would be 5 times 9. 5 is a prime number. 9 needs to be split into 3 times 3. And 3's are prime numbers. So for 27, I've got 3 times 3 times 3. And for 45, I've got 3 times 3 times 5. Okay, pair up. Scrub out a duplicate. Right, just to prove that you can still do it on the scrubbing out a top row, I'm going to scrub out a top row. Let's say, I personally would scrub out the bottom row, but it doesn't matter. Okay, I'm going to get rid of the boxes because they could be confusing. So we know that this one makes 45. And the only thing left here is a times 3. So 45 times 3, you could just add up 3 45s if you wanted to. However which way you want to do it. So that's 15, 4, 8, 12, 13. So the answer is 135. Okay, hope that made some sense. It is do a factor tree, pair up, scrub out duplicates, times your bits together. Alright, anyway, catch you later. Bye!